so it can be linked to whatever application you're working on. Auditability, of course, you can look at the code and see what's actually going on. And it's written in C, and it's not 4,300 files. If you're the kind of developer that needs to do BIOS extension or firmware extension, then Coreboot is great because we just have one source tree for all the mainboards, whereas said BIOS vendor, they actually fork the entire source tree of their 4,000 files for each mainboard. And this means that new features added to one mainboard doesn't always get included on other mainboards, but they think it's a feature because when you have this board out in production and the BIOS software out in production, and you only want to make a small change, then you don't want to have to pull in all the changes from all the other mainboards, but you want to do just a small change and send out a new version of the BIOS. I guess they don't know about tags and branches. So the one source tree makes reusability and extensibility a key factor, I think, in Coreboot. We still have work to do, of course. We need more testing. There's a great testing framework that Google sponsored development of that actually does runtime testing of every single commit on actual hardware. The only catch is that someone has to hook up that hardware to the testing system, and we don't have very many of those setups yet. I'm a perfectionist, so I dare say that few boards are really 100% working. Maybe just one. It's an Asus K8 M890 board. I don't remember the exact model. But there are a lot of main boards, both embedded desktop and server boards, that are not very far behind. ACPI is one thing that we are getting better at. It's pretty hideous, but we really can't do without it for some operating systems. I hope that will change in the future. I so hope that will change. And I think Coreboot will actually play a big part in that. I hope others agree with me too. And I often get a question about laptops, because everyone wants this on their laptops. The hard part about laptops, it's doable, but in laptops, even if the chipset and the CPU is really similar to a desktop or a server, well, maybe mostly a desktop, there's this extra small chip, a microcontroller, that is doing some special tasks, handling the whatever function keys you have on the laptop, and handling the lid open-close buttons, and some power management, battery charging, etc. The sad fact is that manufacturers like HP or Dell or whoever, they don't know really very much about how this embedded controller works, because it's developed by two guys sitting at their ODM, the design manufacturer in Taiwan. And they don't really have any channels to get documentation out or to get some contacts through so that we can talk to them. And that, of course, means massive reverse engineering work, which is doable, but it takes a lot of time and effort. We're hoping to find some vendor that is interested in getting Coreboot onto a laptop, and we're working on it, but progress is a bit slow. If you know any vendors that are interested, please come talk to me. But there's a lot of fun stuff ahead. So I want to say some personal thanks, in particular to Uwe Herrmann and Jacob Appelbaum, because their research on, Jake's research on cold boot and Uwe's RAM dumping stuff in Coreboot led to me ending up at the Metrolographics camp this summer, which was a fantastic time in Italy. And I also want to say a huge thanks to the Chaos Engels, because this event is probably the best event in Europe, and without their work it wouldn't be possible. So we have some information up on the web. If this wasn't enough, we have the mailing list, of course, and an IRC channel. Please come talk to us or me. coreboot.org/philo/libpayload etherboot. Most of the stuff I've been talking about has its own wiki page. And there's a search function, of course, on the wiki as well. Do we have any questions? Do we have time for questions?
Yes, I certainly do have some time for questions.
Okay. Any questions? I see over there, over there.
Just make sure it's working. Yeah, it is.
I have two questions. The first one is, I own the same board, it's Alix 1C, but there is JTAG access. So my question is, how have you flashed the chip? Because it's not a flash chip that you can just take
Excellent.
out. It's soldered on the board.
Excellent question.
And second is, yeah, I think I forgot the second question.
So let me answer your first question, and maybe you'll think of the second one again. It says there, I'm doing a workshop tomorrow evening at 10, where we are going to play around with the Alix 1C and flash coreboot into it if you want to, if you have the board. The Alix boards are really hack-friendly because they have a special jumper, and you can order a spare flash chip from the manufacturer for €4, I think, which you just plug on to the header, and it overrides the flash chip, which is on the main board. Really easy to work with. If you have a desktop mainboard or any other mainboard that doesn't have this feature, of course it can get a bit more tricky if you don't have a socket. If you're skilled with soldering, or you know someone who is, just take off the flash chip and solder a socket on there instead. It's not crazy impossible, it's doable. But in the end, if the chip is soldered down, and also there are some surface mount chips that are a bit difficult to work with, then maybe it's better to look for another similar board.
Okay, the second question was about JTAG. Have you investigated how JTAG is? I mean, on the Alix you have JTAG access, but on other laptops sometimes the CPU has JTAG pins, but sometimes they are not wired on the board. And have you investigated how to get coreboot flash with JTAG?
Well, okay, getting it flashed with the JTAG may or may not be difficult, a bit depending on how the board is laid out and how the JTAG chain looks. The thing with JTAG, if anyone doesn't know, it's a sort of a serial bus where all the major hardware components on the main board are connected together in a chain. And if you know how each component works inside, you can control the component completely using JTAG. If it's a CPU and you know how the CPU works, you can single-step instructions over JTAG. You can inspect all registers. It's really a superb hardware debugger. The catch is that you need to know how the chip works inside, and getting those description files for the interesting components is next to impossible. Or if you're going to do it yourself. The option is, of course, to buy a Lauterbach or some other equipment for maybe a few €100,000, but that's not really within the reach of enthusiasts, unfortunately. If you're doing a business project, maybe, but it's still pretty expensive equipment. And JTAG on x86 systems, unfortunately, it has a high threshold before it's usable. Did that answer your question? Sorry? Yeah, okay.
There's a question over here as well.
How large are these flash chips? Because you had virtualization on there. Would it actually be feasible to implement a hypervisor in a flash chip?
The Xbox 360 has a hypervisor in mask ROM, so yeah, sure. Just depends on how competent it should be. But yeah, a simple hypervisor, no problem. To answer the question, how big are these flash chips? That's also a good question. It varies from, I would say, 4 megabits to 16 megabit on the main boards that are out today, and flash chip size is measured in bits, so that's half a megabyte to up to 2 megabytes. Half a megabyte is pretty tight if you want to squeeze a Linux kernel in there, but 2 megabytes is already somewhat roomy, and most of the times these flash chip interfaces, they also allow you to put an even bigger flash chip on there if you only order one, and the cost isn't, there's no real big difference in cost for these flash chips. So if you have a socket and you can fit a bigger flash chip on there, go for the largest one you can find so that you can play around.
So my question is, what has Coreboot done as... I'm right
There,
here.
okay.
What has Coreboot done as to system management mode? Is there anything interesting about that Coreboot has implemented?
Good question. We have 2 implementations of system management mode code in Coreboot. I mentioned that system management mode is actually used quite a lot, and in particular on the Geode, AMD Geode, which is used on the Alex board. The normal way of booting the system or bringing up the Geode CPU is to virtualize a number of PCI devices using system management mode. So, and AMD has released source code to that implementation, and they have also started work on porting it over from the Microsoft development tools, the macro assembler and so on, onto open source GNU tools. That second version doesn't run yet, but the code is there to look at and to hack on. And we also have a second implementation of system management mode handlers in Coreboot, which is for the Intel 945 chipset and coupled with the Core, any Core 2 or Core CPU. So there are 2 different frameworks for system management mode experiments if you want to do those. Answer your question? Yeah.
In BIOS and OpenFirmware, we have possible to load extension ROMs. So how is the concept of integrating like future hardware concepts into Coreboot in the future?
That's a really good question. At the moment, we can use CBIOS to run existing option ROMs. We can also run them in an emulator, x86EMU, or we can run them in BM86 mode. Personally, I just have one idea for this, for the really long term. I want to run Linux as my bootloader, and sorry, I of course want Linux to have drivers or have the software to initialize all this hardware. So I don't know if you've heard about this, but Fabrice Bellard, the guy who has done a lot of work on QEMU, he's also written a C compiler called TCC. TCC is able to compile a full Linux kernel in, I think it was 14 seconds. Pretty impressive. So my sort of idea for something that would work is to have, first of all, Linux software, be it a kernel module, preferably not, but worst case kernel module or a simple user space application, do whatever the option ROM does today as far as initializing the hardware. And then if you have Coreboot and a kernel in your server, your SCSI card fries and you have a replacement in the shell, on the shelf, but it's not exactly the same model you need in your driver. Okay, out with the old one, plug the new one in. You boot up, plug a USB drive in with a kernel source. TCC builds the new driver for your kernel. It takes maybe 10 seconds. Reboot again, or maybe just load the module into your Linux kernel because you're in utility mode right now. And kexec, your kernel, which is your main system kernel, which is on the RAID drive, and off you go. That's my vision. I would really like that. A lot of work hasn't been done yet, but